Welcome back to the course Asynchronous Programming in C#. I'm Philip Ekberg, and now we are going to look at parallel LINQ. This module requires that you understand the language integrated query, also known as LINQ. We're going to explore how to use LINQ to perform parallel processing. You can use LINQ to write operations that filters, converts, sums, or works with collections of data in heaps of different ways. The goal is to apply a parallel layer to vastly improve the performance of that operation. This is where parallel LINQ is introduced. Parallel LINQ will work with both the query as well as the method syntax. PLINQ or parallel LINQ is a parallel implementation of the language integrated query, meaning that you can take some LINQ code and very easily change that to execute in parallel. Depending on what the query is doing, this may or may not run in parallel. Whether or not it does depends on an internal analysis of that query. A prerequisite, of course, as we've discussed many times now, is that each operation needs to be completely independent. To start writing parallel queries, you first need a collection of data to work with. Once you've got an IEnumerable of t, you can simply call as parallel, and this will create a parallel query. To execute the parallel operation, you could simply call a method like sum or toList, or use a for each loop. In this example, you have a short list of elements. Each element will be passed to an expensive operation for it to be processed. When this is run sequentially, it uses one thread for all the processing. Let's say that it takes a few seconds to complete. If you simply add as parallel, the query will instead run as efficiently as it possibly can on the current system. The operation will then use all the available resources, very much like we've seen previously with the parallel operations. The result will therefore complete much faster. The parallel query produced by the call to asParallel will expose functionality to configure how the query will execute. For instance, the parallel query class exposes methods for setting a cancellation token and the degree of parallelism, as well as a bunch of other useful configuration capabilities. Each of these different methods return the configured parallel query. This means that you can build really beautiful method chains. When the parallel query is created, you should know that this does add a fair bit of overhead, as it needs to be able to analyze the query that you are going to perform. Keep in mind that it needs to handle all the threads or tasks internally and also make sure that it runs as fast as possible. This means that you shouldn't overuse asParallel and simply think that everything will run faster. It may in fact result in more overhead and an overall slower application. If you have a parallel query and you'd instead want that to perform sequentially, meaning you don't want any parallel processing, you can retrieve an IEnumerable by calling the method as sequential, which means that it will then allow you to sequentially process data. This can be combined with asParallel. This will allow you to perform parts of the query in parallel and other parts of it in sequence. As a word of caution, you won't be able to convert every LINQ operation to execute in parallel. It very much depends on the purpose of that operation. When you execute the query after you've added asParallel, the query will be analyzed before executed. This allows for two important decisions. If the code is faster to execute Without parallelism, it will do so. If it's unsafe to perform the operation in parallel, the query will be executed sequentially, like a normal LINQ operation. This behavior can be changed by setting the parallel execution mode. You've got two options here. Either you use the default behavior, which will be best for most cases, or you can force the query to execute in parallel, even if the analysis determines that there's more overhead doing so. You would, of course, only do this if you are absolutely certain that the operation will be performing better overall, and that you don't care about the extra overhead and potential implications. With that being said, I would really recommend that you stick with the default behavior. You shouldn't assume that just because you add as parallel, your queries will run faster. In fact, you will most definitely only see a performance improvement for larger collections, where each item needs to run through some time-consuming operation. Just as we discussed in the previous module, if your code in the parallel operation needs to lock for a long period of time, that won't necessarily perform better than a normal sequential operation. Instead, you'll end up with even more overhead, both memory-wise and computation-wise. Therefore, make sure that you avoid locking and overusing shared resources. This isn't just for parallel LINQ, but it's something that you should keep in mind for any situation where you introduce parallel processing. Follow these guidelines and best practices that we've discussed through this entire course when you apply your parallel LINQ, and your applications should be much more performant. Next, let's look at how to produce a parallel LINQ.